In 1972, Intel introduced the first commercial microprocessor. Not the first microprocessor, but certainly the first commercial. Um, that was today. It seems like there are very few applications that remain that a person can find where these microprocessors were actually used. And I've only been able to come across 4 different source files for the 4004. That includes talking to Intel's museum, etc., etc. So um, one of the more interesting things about the 4004 is that at that time 4004 was coming out, Gary Kildall had been doing contract work for him in order to write what they call their PLM programming language. So he was also working at the Monterey Peninsula Naval Postgraduate School in Monterey, and he was able to acquire what he called broken hardware from Intel in order for his students to have hardware to work on projects. And some of it included the 4004 and later on 8008 and 8080. So Gary Kildall was very involved with some of this stuff at the very beginning. There were 2 projects that were done on the 4004 at the postgraduate school. One was a a load calculator for calculating how much weight you can put on your helicopter and still safely take off. It, of course, used parameters such as there were, of course, the static parameters like the actual helicopter you were using, how much fuel you had, what the temperature was, what the humidity was, all the factors, and the altitude, of course. So you needed to have all of these factors to know when it was safe to take off. The thing that most interested me was the other project that was done that was a maneuvering board, electronic maneuvering board. Anybody that stood a watch on a bridge of a ship knows what a maneuvering board is, because they have to use that to calculate when they are possibly on a collision course, or even in like wartime, for instance, in a submarine, for instance, knowing where they need to go to be on a course for intercepting an enemy ship, something of that sort. So the maneuvering board was quite interesting. So I downloaded the paper that they had, which included a listing that of the program, and also a brief description of what the hardware looked like. They had what they called a schematic of it. The schematic included the layout of the lights and the switches. So that was their schematic diagram, which I thought was interesting. So years ago, I found this software and always wanted to create a working 4004 program for it. And I'm close right now. Some of the features in my hardware, I've got some of the levels inverted. Remember that the 4004 was PMOS, and ones were minus 10 volts, and zeros were plus 5 volts. So that made it kind of, you had to constantly think which level you were talking about, whether it was a TTL level or whether it was a PMOS level. So I got some of it wrong, but needless to say, I'm very close to having it functional now. Probably in the next month or so, I'll finish off the software. I'll make software changes right now rather than make hardware changes. So anyhow, I got the listing, which had the raw instructions, but the listing only had line numbers, and it did not have anything about the actual code that goes in there. I wish they had the code, but they didn't, because a lot of the listing was apparently done probably on a RS 33 teletype, and had a really bad platen on it, because what happened is certain columns, you could see where the characters zeros and C's looked the same, and letters like P and F looked the same. So a lot of it had to do with not only translating the listing into a computer readable form, which of course you couldn't do in OCR because of the poor quality, and actually getting it up to a working program. So part of my project, which I didn't show here, but I made a simulator for the 4004 in software, and actually debugged the code to get it all so it was ready for operational to try to blow on an EEPROM. The project took, like I said, I've been working on it off and on for several years. Some of it required pieces that were hard to get. I had an extra 4004 processor. I had some of the RAM I needed and some of the other parts. And just recently I've been able to acquire the final pieces. So I use KiCad to generate a circuit board, and it still has a few features that I had to hand cut wire and stitch the correct wiring in. But so we can kind of get a look at what I built, and then we'll take a look at the actual PDF that I downloaded from the library there at the postgraduate school. This is the board I built. You can see there's a 4004 in the corner over here. There's a series of 4002 RAMs. There's dash 1s and dash 2s scattered across here. The lighter colored ceramic ones are dash 2s and the plastic ones are all dash 1s. There's I'm using the original probably used a 4008, 4009 set, and I'm using the 4289 chip. And rather than trying to make my own clock circuitry, I'm using a 4201A clock generator here for the clocking of the device. This really should have been all done on a 4-layer board, but I tried to do it as small in the space as I possibly could because it's a proto board and it's by the square inch, and it was already a couple $100 for the prototype. So, but it should have really been done on a 4-layer board. Just to show you what I mean by I had more screw-ups. If you look on the back here, you can see the extra wires that I had to cut and jumper to make things right. This is all the wiring off to the switchboard, and I'll use little switches. I'm going to run it a little bit. The display doesn't work, but I believe it's all a software problem, because which I will probably modify. I have another ROM that I use to test out the actual displays, so I know the displays are functional. It's just that they're not quite right. This light that's lit is actually a status light. It's supposed to mean there's an error, but like I said, getting my levels, what's 1 and what's a 0 confused, it's backwards. It's a relatively easy fix. I can just use another pin on the 7474. So that's pretty straightforward. So anyhow, you can start off, for instance, like you can put in the speed of your ship, and so you can tell it what the speed of your ship is. Like I can tell it's 12, and then I could tell it that I'm on a course of maybe 90 degrees or 95 or something like that, 95, and then I can hit the own ship switch here, which you saw a momentary flash there, but that was supposed to have done something more meaningful. But anyhow, if you did something out of order, the light will go off. So like if I at this point just type a number, you can see that what it's really supposed to be doing is turning all of the displays off and turning that light on. So it's kind of going backwards. So I know all that stuff is working. It's just a matter of actually getting my levels right. And I'm not too opposed to actually changing the software to fix that. One thing that was hard to get was a power supply. You notice my UL approved blue tape over the power leads. Most of the dual power supplies are 12 and 5 used for disk drives, and the grounds are actually hardwired together. You can't separate them. So I had to find a power supply that I could use the plus and minus supply rails on it as truly plus and minus rather than plus and plus. So that's it for that. And like I said, it looks like it's coming along. I'll be able to fix the display pretty quickly. It's just a software change. I had some problems with my programmer and some other problems along the way, so it's always a constant battle. This is a diode matrix, of course, for the switches. There's 27 switches out here, so it makes it a lot of fun to try to mux those all into the processor. Yeah, this is the title page. This is the name of the library where it's kept. And I see Naval Postgraduate School here, archives. Uh, uh, this Kenneth Harper and Kearns were the primary authors of this paper. If you look at some of the code here, you'll notice over here, first off, you get line number uh, in hex, line number in decimal, and then number of the page you're on, the 256 page, and the address of the page that you're on. But notice there's no actual code here. It's all over here. There was multiple instructions per line, which actually kind of made sense because you had different things you wanted to do. You can see these little RCs here. I believe these are actually R0s. So you can see that they got dropped off. You can see the M over here is missing the edge of the M, and you can see a few other misses. This is really an F because when it has quotes around it, it's meant to be hex, and the values that are just numeric values are always in decimal. So anything with quotes is a hex number. Anything with decimal is just a number. But you can see, like here, this is obviously XCH. It's missing the part of the H, things like that. So it was quite a bit of effort to get the listing first typed in, and then try to run it to actually see where the problems were in the simulator, and then actually repair the actual listing, both for my typos and for 0 versus C, which was the worst one.